Hello students, welcome to this session. In this session, we are going to discuss certain important terms pertaining to sound under Chapter 13 of your NCERT Science book 8th class. In previous three sessions, we have studied how the waves are produced, what are the properties of waves regarding oscillation, vibration, frequency, amplitudes, speed of sound wave, etc. we have already studied. Please watch those videos so that you can get benefit from those videos. In this session, we are going to discuss the types of waves, particularly the sound waves. Thereafter, we will discuss the loudness of sound, pitch, shrill and flat sounds. And at end, we will discuss audible range of sound for human ears. Firstly, we will start discussion on types of wave. In previous session, we have studied that waves are produced by certain disturbances, external disturbances. That means by mechanical or external efforts. And vibration are nothing but vibration are defined as disturbance in the medium, particular medium, as water, air, etc. When certain disturbance is caused by certain external efforts or mechanical efforts, vibration starts among the particles of medium, and vibration propagate bearing certain amount of energy. In other words, we may tell that vibration is nothing, waves are nothing but disturbances. So here one main property of the waves we should know, that as they are produced by certain mechanical efforts, so they are called mechanical waves. This is one of the type. Mechanical waves. Waves are called as mechanical waves, particularly the sound waves or water waves, which are caused due to certain disturbances or due to the effect of certain external effect or mechanical efforts. So they are under the categories of mechanical waves. And you should know this is very important information on examination point of view. Mechanical waves require certain medium for their propagation, for their transmission from one place to other place. This is the reason the sound waves require medium. Without medium, the sound waves cannot transmit from one place to other place. In vacuum, they cannot transmit. Medium may be air, water, solid also. In solid, their speed of the sound waves are more than water and air. Approximately 5,100 meter per second is the speed of the sound waves in solid metal, particularly iron or any metal, solid, you may write. In liquid as water. In water, the speed of sound wave is approximately 1500 meter per second. While in air, the speed of sound waves is approximately 340 meter per second. This is the normal speed of the sound in air. Just we are speaking, our voice move by this speed in normal condition. It depends upon the humidity in the air, in atmosphere also. Now, here we will also discuss certain type of electromagnetic waves. Here, in the case of mechanical waves, particularly in the case of sound waves, we found that propagation or transmission of the sound wave or any type of mechanical waves require certain type of the medium for transmission. But electromagnetic waves like light, they do not require any type of the medium for transmission. Example, sun. The sun rays are coming from the sun. There is space. In space there is no medium. So light rays do not require any type of medium for their transmission. Clear? Now we will discuss the types of waves on the basis of movement of particles in respect of propagation, direction of the propagation of the waves. On the basis of to and fro movement of the particles in respect of direction of propagation of wave, there are two types of the waves. First category is transverse wave. Second are longitudinal waves. Just by an activity, we will understand these types of the waves. Certainly, you have played with the slinky. Slinky are pre-compressed helical spring. Most of the students and most of the children used to play with the slinky. You fix the slinky with a point and then you move the slinky by holding the other end up and down. In that case, the particles of the spring will do up and down, to and fro motion. And here the direction of wave is this horizontal line, in horizontal line. That means the to and fro motion of the particles is perpendicular to the direction of the waves, vibration. So in this case, this is the example of transverse wave. Now we will define the transverse waves. In transverse wave, the particles of the medium perform to and fro motion just perpendicular in perpendicular directions to the propagation of the vibrating waves. Vibrating waves. That means that movement to and fro movement will be perpendicular to the movement of the wave, direction of the movement of the wave. Thus, now by another experiment, another activity, we will understand the longitudinal wave by same slinky. Now we will start pushing and pulling. That means by holding the free end, once you push and then you pull the slinky. In this case, the to and fro motion of the particles of the spring or slinky will be just parallel to the directions of the transfers of energy, or the, you may tell, movement or propagation of the wave. That means here the particles are performing the to and fro motion parallel to the directions of the propagation of waves, and these type of the waves are called as longitudinal waves. Example of longitudinal waves is drum or tabla. When the artist slap the drum, diaphragm of the drum or tabla, longitudinal waves, longitudinal sound waves are produced there. Or in the case of longitudinal waves, their successive two regions are formed. For certain distance, certain length, the compressed regions of the waves are produced. After that, some stretched regions of the waves are all produced successively, alternately. Here the stretched region is called as rarefaction, and this is the compressed region. This is the stretched or rarefaction region. These are the property of longitudinal waves. And examples of transverse waves. A string of sitar or guitar. In the case of sitar and guitar, when the artist play and stretch the string, the transverse waves of the music is produced. Now we will discuss the loudness of the sound. Certainly, you experience in your day-to-day life that somebody is speaking loudly, somebody is speaking very slowly, some students are whispering with each other, and on road, sometime you hear certain loud sound. Loudspeaker is producing very loud sound. Certainly you have heard. So the loudness of the sound depend upon the amplitude of the wave. We have already studied regarding amplitude. The loudness of sound or sound wave is directly proportional to the square of amplitude. Square of is directly proportional to square of amplitude of the waves. Square. Suppose you are increasing the amplitude 2 times, then loudness will be increased 4 times. 4 times, because it is proportional to square of the amplitude. Understand? That means the loudness of the sound depends upon the amplitude of the waves generated or produced there during the vibration, during disturbance of the medium. Loudness of the sound depend upon the distance between the source and the observer, or the person who is hearing the sound. If this is, suppose it is source, and here one person is standing. It depends upon the distance between source and the person who is hearing the sound. If the distance between the source and observer increases, then loudness decreases. If the distance between observer and source is decreasing, then loudness will increase. So here we may tell that the loudness of the sound depends upon the distance between the source and the person who is hearing the sound. Now, one thing we should know here that is very important. The loudness of the sound is measured in unit that is called decibel. Decibel. It is denoted by a small d and b. Decibel. Decibel. The range of loudness in different situations we will understand, we will study here. Our breathing is having 10 decibel loudness of the sound. When the two person or one person is whispering, the whispering is having 30 decibel loudness. We are talking, that means conversation, normal conversation between the two people, two boys, is having 60 decibel. 60 decibel. And when in busy traffic on road, their sound produced is normally 70 decibel. But in factories, there is more noise in respect of road or traffic. Their loudness of the sound produced in factory is 80 decibel. These are the different measurement of the loudness of the sound in different situations. Certainly you have heard, particularly the human voices. Somebody has flat voice, somebody has shrill voice. Particularly the girls are having the shrill and sharp voice. Boys are having flat voice. Men are having flat voice. So what are the reasons? Why the girls, women are having very sharp or shrill voice, and boys and men are having, and boys and men are having flat voice? What are the reasons? The shrillness or flatness of the voice, shrillness and flatness of the voice depend upon the pitch of the voice. And pitch, in other words, the shrillness or flatness is called pitch of the voice or sound. Pitch depends upon the frequency of sound or frequency of voice. Clear? Pitch is proportional to the frequency. Pitch is proportional to the frequency. If frequency is greater, then the sound of greater pitch will be produced. The women and girls are having higher or greater pitch. They have ability to produce sound or voice of higher pitch. What is the reason? Just here we will understand. We know that we are having larynx or voice box in our throat, in pharynx particularly. In next session we will study the structure of larynx and ear in human beings. So larynx has certain part which vibrate to produce voice after getting the instruction from the mind or brain through the nerves. That part is called as vocal cord. Vocal cords are found in larynx or voice box. When the instruction comes from the mind, brain, the vocal cord start vibrating, and due to a specific type of the vibration, a specific type of voice is produced in our buccal cavity, mouth. That is the speaking, that is the voice which we utter. The girls or a small child, as the children are growing, this is the reason. So their larynx or vocal cords are not so developed. They are in the course of development. And vocal cords of children and girls and women are smaller than boys and men. This is the reason. As their vocal cords are smaller in respect of men and boys, the sound produced by their vocal cords are having a smaller wavelength. Sound produced by the vocal cords of the girls, women and children are having wavelengths smaller than man or boys. Here we should know that wavelength is universally proportional to the frequency, inversely proportional to the frequency of the waves. Frequency. As the wavelength of the voice produced by the girls, children, and women are having a smaller wavelength, so the frequency of their voice are greater. Just I told you, the greater frequency or larger frequency produce the higher pitch. This is the reason why the voice of the girls and infant, small children's and women's are shrill, because their voice are having more frequency. Clear? And contrary to them, the vocal cords of the man and boys are larger. So they produce the voice or vibration, sound vibration having the greater wavelength. So the sound waves produced by them are having a smaller frequency. So their voice is flat. Clear? This is the reason why the girls, women, and the small children's voice are shrill and sharp. On the other hand, why the voice produced by men, boys are flat. Now we will understand the audible range of the sound for human ear. The audible range of the sound for human ear is between 20 Hertz to 20,000 Hertz frequency. We can hear the sounds or the voice having frequency between this range, 20 Hertz and 20,000 Hertz. Below this range, we normally can't hear. And above to this range, we also can't hear. And the sound waves having the frequency less than 20 Hertz are called as infrasonic. Infrasonic sound. Clear? And the sound waves having greater than 20,000 Hertz frequency, they are called as ultrasonic sound. Some animals, like dog, can hear the sound less than 20 Hertz and more than 20,000 Hertz frequency of this range. Clear? Dog may hear the infrasonic sound or ultrasonic sound also, less than 20 Hertz or 20,000 Hertz. By these terms, I am going to conclude this session. In next session, we will study the a structure of voice box, larynx, that is larynx, and a structure of human ears, so that we can understand the voice productions and hearing phenomena in the case of human being. You students link yourself with Institute's YouTube channel. There are number of videos pertaining to other subject also. You subscribe our channel, also share the videos to your friends, get benefited, as well as you help the institute in promotion of YouTube channel. Thank you very much.